Lovely. I love being muted. Thank you, OBS. Bro, I literally pressed unmute and it didn't do it. Okay. Let's try this again. Hello, ladies and gentle ladies. Welcome back to another Railroad Development stream. I've lost my train of thought now. Hello, Lone Wolf. Welcome to the stream. Hello, Alex. Welcome to the stream. So yeah, today we're going to be continuing with inspections, and as I was saying, hopefully this will be a simple one we're starting with. Well, I say simple, it's not going to be simple, but it shouldn't be too complicated either. I'll briefly show you guys what we're aiming to do today, since it's easy to demonstrate. So let's say we have an optional of a string. Okay, we'll just say this is, we'll just say, no, we'll say it's a null, like it doesn't really matter. And then basically what we're aiming to do is we're aiming to say, if we do string, my string is equal my optional.get, we're aiming for this, which is hopefully going to say optional.get without is present check. Because obviously what we should be doing here is we should be saying if my optional is present, then it should do that, right? So effectively that's the goal. It shouldn't be too hard, but it's not easy either. So I think this one is actually classified as a medium, and I would say that's a correct classification. So yeah, I've already created all the like basic stuff that we need for this. Let's just get started. So the best way to start, at least as far as I can see, is to look for everywhere. So the way we do this inspection, by the way, I've kind of already thought this one through. It shouldn't be too complicated. So we just want to look for all of the ifs, the whiles, the for loops, and we want to see if it has an if is present inside of that or not. And then we'll keep track of those, and then we can see where the .gets are called and see if that's already had an is present. So we kind of like do it in reverse, because that's just the easiest way to do it, rather than like trying to backtrack, because I don't know how you would even do that. So I mean, let's start with a set, and this will be a set of syntax node, hopefully. Like a bit loud? It's the same as usual. It's literally exactly the same as usual. I don't think it's loud. Maybe you just have me up too high. I mean, I can try and pull it back a little bit. Like, I can try that, but I don't think it's going to make much of a difference. What do you mean Lone Wolf agreed, bro? He hasn't said anything. Oh, music. I see. There you go. Although I'm pretty sure that's the same as what it was yesterday, but sure, that's fine. So this will just be the guards, and we'll set that to a new hash set. And then we just collect the guards. So we only care about if, whiles, and basic for loops. We don't care about enhanced for loops, because enhanced for loops don't have conditions, and we don't care about do whiles, because do whiles just like don't do, you know, if you have a do while, it's not really valid here. Music's now too quiet, guys. What do you want from me? There, that's half my mic's volume where it is right now, so that should be fine. So let's collect our guarded. Let's start with the if statements. Or, well, no, we're looking for the gets, right? So the guarded gets from the if statements. And that just takes in context guards. Doesn't need the reporting because this just collects them. It doesn't report anything. And then we will have gets from... Oh, conditionals is something we should consider later. We'll come back to those because those are like a little bit messier. Okay, we'll have while, and then we'll have for, and then basically we just want to look for all the method invocations. Yeah, as this says. I don't think that's quite correct. I don't think it's far off, but it's not quite correct. Yeah, it's really not far off though, which is pretty good. So we'll just pour over these, and these are the invocations, right? And then we'll have some kind of method that determines if it is the thingy, because that's just easier if we do it like that. So we have like is optional gets invocation, and if it's not one of those, then we just continue. If the guards contains it, continue, else we just report the invocation. Lovely. Pretty simple. It's a good start. Okay, so then next, let's create this method first. I think that's kind of the most, like, powerful, I guess. So first of all, we can check, yeah, if it's a method invocation. I think the method is not called that though. Yeah, it's this one. And it's just, yeah, okay, so that just checks that it's a method invocation and it's called get. Pretty simple. We also want to check that it has no arguments. So if not context, I think once again we have a method for that. I vaguely remember this. And then from there we have to get the receiver. So that would work, but I think an easier way would just be to get the receiver name rather than faff around. So we'll do receiver name. Then let's check that exists. It does in this case. And then, I mean, that should always theoretically exist, but like, it's fine. So then we'll do, then we want to actually get the invocation receiver from, I think no, it's from the invocation, isn't it? Yeah. So this will be the invocation receiver. And then from that, we can get the receiver by doing context.unwrap. If that's null, we skip, and then we just need to get the type of the receiver, right? I don't remember what the type we're looking for is. But we're looking for the inferred type. Oh, it's a type, like a Java type. Okay, that makes sense. So we'll just do receiver or else null dot var. And we'll just call that the receiver type. Okay. And then if that's null, return false. And then we can just get the qualified name. Type name, I should specify. Can we do that? Yeah, that's not a thing. I didn't think that was a thing. We need to get it from the context. From receiver type. And then Ooh. Ooh, Copilot has brought up a mighty thing here. Because optional is not final, is it? Oh, it is. Oh, interesting. Okay, I guess we can do it like that then. There's optional long, yeah. Are there any other optionals? Wait, those are our things, are they not? Yeah, they are. So why is it not showing them here? What if we do... Can we do just the libraries? No. Okay, yeah, but we have optional double, optional int, optional long. Is that it? There isn't like optional floats, I don't think. And there isn't optional strings, there isn't optional shorts. Yeah, I think that's the only ones. Oh, we need to get the display name, do we? Possibly. I mean, we could probably just pass in the receiver here. Couldn't we? Check if we can just pass in. Oh no, we can't because... Oh no, maybe we can. I'm not sure. What do you mean they're not being optional floats? There isn't optional floats, they don't exist. You can have an optional overflow, but you can't have an optional float. That's just not a thing. Okay. So then we want to create these methods, right? Let's start with this one. So context, and then we'll just call these like... Yeah, I prefer the name guarded gets. That's actually a good name. Thank you, Copilot. Let's actually rename those here as well. What's the difference between optional of integer and optional int? I don't think there is a... Oh no, the difference is that I think optional int is a primitive int. Is that right? Yeah, it's a primitive int. Whereas optional of integer gives you an integer... Oh, I can't type in here. But like, for example, if I have optional integer, my opt integer, and do my opt integer dots get, yeah, which means that could be null, which would be weird. I don't know why you would have that, but you could, when you should use an optional int, because if we do my opt int dot get, oh, it's actually get as int. Ooh. So why is there an optional double, not a float? I don't know. I guess you would just use a double for a float. But this isn't going to work. Because like they're not called gets. That's the problem. It's get as int or... Okay, we won't do those for now. We'll maybe come back to them. Can we comment these out, actually? That'd be ideal. There you go. These are commented out because we only look for methods whose name is get when these types actually have get as int blah, blah, blah. Get as long. Right now, Lone Wolf, it is 7:20. What do you mean it gets light at 5 p.m.? How the hell does that work? Oh. Because you're on the equator? Or near the equator, I guess? I assume that's why. $7 p.m., not a.m. That would be crazy. 21:20, if you will. Okay. Get rid of that. So, yeah, kind of what we want. Okay, let's just do syntax node condition. And I added a method just before the stream to help out with this. So we have a condition of, which just saves a bunch of time. So we can now use that here. So if condition is null, we continue. Then we need to extract. Well, we need to extract whether or not it's an is present, right? So I think let's try and create a fact, I guess. Optional presence fact. And we'll pass in a string receiver name. I can't lie, for records, I wish you could just put a semicolon on the end. It's kind of stupid that you have to open some curly braces. Like, even though I don't have a body, I still have to open them. They should definitely add that. I wonder if that's even being suggested or not. Either way, they should. Because that'd be lovely. But that's not gonna happen, so. At least you have access to records. That's true. We need to update to friggin' Java 26 at some point, or 25. I don't know which. Is 26 LTS? What's the LTS version right now? Oh, it's 25. 25 is LTS. Does it say what the next one's going to be? Java 29 is going to be the next LTS version. That's crazy. So we'll have to wait till September next year, apparently. But for now, we should probably update to 25. But not right now, of course. We have more important things to do. So let's extract the is present fact, and then if that's not null, we can get the then branch. This feels very similar to what we did yesterday. It kind of is in a way. What's wrong with that? Oh yeah, I meant syntax node. And then we just want to collect. Well, yeah, I suppose we want to do then branch is not equal null. Then we will collect matching gets. Yeah, sure, I guess. And then we'll just extract the negative ones and basically do the exact same thing. Okay. So then we want to create... Let's create this method first, I guess. Hello, Wide. Welcome to the stream. What do you mean triple T? How does that work? Well, I guess there technically are 3 T's, but like, why? why are you calling me triple T all of a sudden? Why? That's more work than saying TW, so why triple T? I'm not sure I'm following. Okay. Java. Context, and syntax node condition. Okay, so I mean, this should be syntax node current is equal context. Unwrap it, and then if current is null, return null, and then can I sleep with your stream on? Sure, if you want. I mean, I can't exactly stop you, can I? A bit odd, but if you really want to, well, I mean, you have free will. Current.kind.id, and let's check that it has the and token. Token? I don't know what the method's called. That one. That's the one. And then current, and the token type is and. Okay. Let's plonk that down here. And then let's do operands of binary expression. Yeah, kind of, but I don't think we need to do it like that. I think that's a weird way to do it. And we don't, that method doesn't exist, right? Yeah, I don't think so. We can just get the 2 expressions, right? So the children will be expressions in a binary expression. The 2 children will be expressions other than the operator. So the operator would be the second child, but that's not an expression, so that'll work. And then we'll just say of current, and we'll say for child, and then yeah, basically do that, I guess. Okay, and then Here, we want to just return null. Because if we don't have a fact from those, then we're not going to get one. Then let's check if this is the invocation. If it's not, we can return null. We can get the receiver name, check that, and then we can just return that on that receiver name. Boom. Not too shabby. And then let's just do the same for the negative one, I guess. So let's come down here. Now negative is simpler. So we get the current. Get rid of all this. I don't think we need all that. Negative, we can just check if it's a unary expression. Java syntax clients.unary. Yeah. Too many braces. This needs to be not or exclamation mark, I guess. Sure. We can kind of simplify this one, I guess. Just say if not that, return null. Not that, return null. And then we can get the inner context. That'll just be the first expression. Because obviously if we're doing not something, then the something is the expression, so that's just the first expression. And then if that's null, return null. It won't run on a new line. Hello? And then yeah, just extract the positive from that, right? Because now we know that's negated. So we just extract the positive. Only thing is, like, is that gonna work with like not false? I actually don't know it will. Maybe come back to that. Let's plonk a to-do in here as well. Not sure this will work with multiple exclamation. Hello Reels, welcome to the stream. Okay. Are we just left with, we're just left with these now. Is that right? Are we just left with these? I think so. Yeah, okay, let's do these. So this is gonna need a lot of recursion, I think. Railroad has indeed advanced quite a lot, yes. Especially from how it used to be. Definitely. Definitely has. This is just the body. This isn't really a then branch because this is also going to be used for the else, right? And this is just a fact. Guarded gets is fine. Okay, if body is null, let's just return. And then we'll just have a recursive method call that we can use. So we'll do private static void collect matching gets in branch, and we'll do Java rule context, basically the same thing, right? So syntax node. I have an optional presence fact and a set of syntax node guarded gets, aka the same as what we had before. I messed that one up slightly. And then yeah, if it's an optional get invocation, get the receiver name, and if the receiver name matches, then we add it, and then we just do the same for the children, right? Oh, this needs to be like recur or something, because that's not going to work otherwise. This needs to be node.children. Apart from that, that was correct. And then here we can just call that. Boom. That's that one done. That's if statement's done in theory. So then it's just while statements. Oh yeah. Which now that we've done like most of the logic, while statements should be like trivial. So we'll just do context.nodes of kind. We'll say Java syntax kinds dot while statement dot for while node syntax node condition is context.condition of, and then first of all we just check the condition real quick. Done. No, we just want continue. What am I doing? Continue. And then we just get the fact, right? Since now we've created that method. If that's null, let's just continue. And then this, right? Body? Don't we have that? And we want a guarded body. But we don't have that. I mean, I guess we can add that. Why not? Might as well. So this is the loop node, not necessarily that. Just also mark this as nullable. Okay, let's get the condition. We can do condition of loop node. And then we can have a boolean scene condition, and then just do loop node dot children dot for child, and if we haven't seen the condition and objects dot equals, I guess objects dot equals child condition, then we set the flag, and then here just basically do if we've seen the condition. And is that a thing? No, I didn't think that was a thing. We just want to check that it's not a token, I think. Because it doesn't necessarily have to be a block node. Like, Copilot's right that in like most cases, yes, afterwards it's going to be a block node, but like it doesn't have to be a block node. Like right here, for example, there's no block node, it's just an expression statement. So we just want to check that it's not a token, really. Do we have, we can do child is instance of syntax token, and then just return null. Is that it? I think so. I don't think that's that complicated. Okay. Sure. So then it's just for loops, right? Which debatably I think is the easiest one. Although, well, it's going to be actually like pretty much identical to while loops, I think. Where is our while loops? Here it is. Let's do them in order, like that. Yeah, I think it's the same, unless I'm crazy, but like, we want 4 statements. We get the condition. That's the same. The only difference, of course, is that this is a for node, not a while node. We extract the fact. And then, yeah, this just needs to be for body of. That's fine. I think that's it. Yeah, I mean, that's it. This I'm gonna rename actually just to facts, just so it's easier to read, even if nothing else. But like, I think that's it. I think that's it. That's it. Let me get Codex to write the test. Can you write the tests for this inspection? But like, I'm pretty sure that's it, and then we can find a new one to do after this is confirmed done. Oh, we should probably look at these to-dos first. I'll ask Codex in a second what it thinks about the to-dos. But hopefully this should work. Let's just look at this for a second. Because this doesn't call the negative one, does it? No. So it's a matter of like, because the thing is, if this method is never called recursively, then that's not going to work. Or at least I don't see how that could work. Unless this does that, like maybe this. No, I don't think it does. Okay, what is it doing? Okay, I think Codex is done. Okay, let's run it. And then what was the other to-do we had? Yeah, this one. I think we can do this one. It just becomes more complicated. But like, yeah, what we can have is a like private static final map of string, which will be like, no, optional type to to get method. And then we can just have optional, get as double, get as int, get as long. Question, does optional double have get as float? That might be a thing. You've got get as double. No. Okay. You never know, it might have done. What about optional long? Once again, I doubt it does, but it might. No, it has get as long, but that's it. It looks like all our tests are failing, so that's never a good thing. Oh dear. Okay, how do we do this though? So we'll have to go through all of them. So we'll have to do like Boolean is no, let's do string expected type name. We'll set that equal to null. And then what we will do is we'll do this dot entry set dot for. Then we'll grab the string optional name get method. If it's that, set it to that and break. And then if expected type name is null, then we can return false. And then all we have to do is do expected type name dot equals. Let's replace this with objects or equals though. And then we don't need all that shenanigans. And then I don't know if we can just pass the receiver type in here or not. Let me ask Codex. Can you look at the to-dos in here? And then let's look at the results. So what is it saying here? Oh, interesting. So that's actually a rule context issue. Okay, wait, what is it saying? Well, what's this one? So this expects there to be an issue. Yeah, I agree. That should be an issue. Let's see what Codex has said. It has said quite a lot. So it said... Oh, it's found a logic bug instead. Okay. So it says... I see. It reckons... Okay, so for this to do, it reckons don't do that. So, okay, that's fine. But it says the bigger issue is line 148. This, if not, is get invocation. Should be checking for is present, not get, apparently. Right. Where are we here? So this is checking. Oh, yeah, that's not right. Do we have a method for that? We don't. Okay. Well, we need that then. Okay. Also, what we need to do, actually... Wait, no, we don't. I was thinking... Do we? I was just thinking, if we have, like, optional string my opt, if we do my opt dot if present, I guess we just have the string, right? But like, if I do my opt dot get, does IntelliJ flag that? It actually doesn't, interestingly enough. Yeah, it doesn't flag that. Yeah, maybe we should consider that at some point, but we can come back to that. It's not important right now. Yeah, I mean, we're gonna want, kind of as it says, we need to replace this. So let's make a method. Private static boolean is optional is present invocation Java rule context and syntax node invocation. Okay, and then basically if not that, basically it's going to be basically the same as the get one, but for this let's get the receiver. If the receiver isn't there, then we can get the type, and then yeah, like that. That'll just check that it's any of the valid types of that qualified name. That's fine. Then we just need to make sure we're obviously using that. Yeah, and then only other thing to do is then the multiple exclamation marks. I guess what we want to do here is like say whilst it has an exclamation mark or something. I guess. Sure, I think that's probably the way to do it. So let's have a counter. Because if it's odd, that means it's negated, right? If it's even, that means it's not negated. So we can do an int negation count, and then while current is not null, and it's a unary expression, then what we could do is we could say if it not has the operator token, then we can break, and then negation count plus plus, and then just unwrap it, right? We're gonna do context dot unwrap, because otherwise it could be in parentheses and whatnot, so we don't care about that. And then if negation counts, we can do percentage 2 is equal 0. We can also do this, right? I think. I'm terrible at friggin' this stuff, but I think that would work too. Maybe. I don't know. Maybe not. It'll probably tell me if not. And then we can just get rid of this, right? And then this just becomes current. Because this basically replaces what we had here, along with this loop itself. So I think that's fine. I think that's it. What it might be nice to do, I'm just thinking maybe we should make this a utility. Just because, like, we're gonna use this all the friggin' time. Yeah. Let's do that. Let's go into here. I don't know where the hell we're gonna put this in there though. I guess it doesn't really matter, to be honest. I'll put that there, but I'd like put that there. I mean, sure, let's just put it here. Yes, it doesn't really matter. Okay, let's start by having like some results we can use. So let's come above this. Okay. We'll put it here, I guess. Whatever. Public record negation unwrap result. Sure, I guess that makes sense. And we can have the syntax node expression, and we can have int negation count and boolean negate. Well, you know what, we can just have a method inside the record. Public boolean is negated. It wants to do that, but I think we can. I'm pretty sure we can do. And 1 is equal 0. Oh wait, is it the other way around? Might be the other way around. That's probably why it's. Sure, we'll just do that. That's easier to read it, anyways. Yeah. Okay, and then we can just have a public negation unwrap result. Unwrap feeding negations. Syntax node expression. And then all we need to do is basically take all of this, I guess. Get rid of that. That's just expression. That needs to go. That needs to go. That needs to go. And just return it, right? Return that. And then all we need to do in here, unwrap leading negations, and then return. The expression is not null, and or we can return expression is null, or or not. Wait. Do we want to check if it's negative or if it's... I mean, I guess we can just check that the negation count is 0. Or we can check that would also work. That may be null. Is that true? That is true, yes. So if that is equal null or that, and then this just takes in the expression. Just rename this to results. That. Yeah. Okay. That's fine then, right? So now we can get rid of that to do. Just get rid of that one. And let's run our test method again. And hopefully it works this time. Let's see. Nope. Not a single one of them changed. Okay, I will be right back, chat. I'm just gonna let Codex figure this out, but I will be right back. Hello, lads and laddies. We are back. Okay, so let's see what codex it says. Okay. It says. Okay, so. Wait, we've already been through this. Okay, it's saying 148 is still not correct. Am I crazy, or did we not change that? No, we definitely changed that. Oh, it says a more important issue is 203. This? It says type receiver type is equal context not inferred type. Where's that? Receiver type here. I think this is the issue. Okay, so it says. You know, should we debug it? Actually, no, that's going to be a pain in the arse to do. We're not going to do that. I changed my mind. Unless we can, if we can avoid doing that, let's not. Oh, it says this is not. Okay. Third type. So it says we should do this. Okay, I think I need to tell it to read the code first. Because it's not reading the code. It thinks I still have the friggin' old code before I rewrote it. So let's see what it says now. Okay, it's doing a little bit more of a deep dive now, so that's good. You guys can watch, I guess, whilst we're sitting here. Let me try and Google something whilst we're waiting. Okay, what's it saying now? What? Yeah, I'm just gonna give it the whole thing. think it missed some. So hopefully that should. Because they're not all in here, are they? No. Oh, it's saying and is wrong. Okay, so... Why is it saying so much? Okay, I should have set caveman mode on, bro. it's just friggin' yapping. Okay, so it wants to write a test, apparently? Sure, whatever. Better do a test, I guess. Okay, and then we'll run it. And see if it says 6 failed. It does say 6 failed. Okay, so it was probably correct with its assumption. So it says the test failed. And it's trying to run it. Why are you trying to run it? Let's not. There you go. So, okay. I'll fail for optional string. That's false, right? Okay, bro, this is what I said originally. Guys, this is literally... This is why I had the freaking to-do here. I was right. This isn't correct. It should be receiver. The codex was like, no, that's fine. I was like, I don't know. Let's see, does that actually fix it or not? Is that actually the issue? I think it might be partially one of the issues, but I don't know if it will change all... Okay, that actually hasn't changed anything. What did Codex say then? Oh, so it wants me to resolve the symbol. Oh, resolve the symbol from the invocation? I see. Okay. Okay, I see. Okay. Does it still want me to get the type or no? No, right, because we don't need it anymore. Right, so it needs to be symbol. Let's just import symbol. Is equal context. Resolved symbol. If that's null, return false. And then here we do owner qualified name. Owner qualified name on symbol. Oh, I see that. That gives... Okay, or else null. Which I think is fine because, yeah, we're using objects.equals here. So that should probably fix it, I guess. Let me bring this back over here, so... Oh, we need to do the same thing in is present. Here. What? No. Why are you doing that? Okay, why is it doing that? We can do... we could do our map What's our map called? Optional type to get method dot contains key. Okay, they still all fail. Literally all of them are failing still. It says my edits didn't land. It hasn't friggin' even read the file. Like, bro, come on. Like, bro. This guy. Let's see, shall we? Bug is 173. Now, let's look at 173. Well, that's right here. So what's wrong with this then, lad? Bro, why is it saying so friggin' much when it doesn't need to say this much? Like, what? Like, there's so much to freaking read it. I can't be asked to read all this. Who do you think I am? Okay. The receiver is the wrong is the optional, not the method call. Right. Oh, we want invocation. I'm guessing we did the same issue here. Yeah, I think that's why. Nope. No, let's just say, okay, can you fix it? And let's see what it comes up with. See what patch it makes. Because I've made the changes it just told me to change and it hasn't done anything. So I don't know what it thinks it's gonna be able to do. But we'll try. Come on, show me. Show me the fix. So it gets the receiving. Wait, what the fuck is it doing? The hell is all this? Okay, this is unchanged. I don't know why it's saying that's changed. It literally is exactly the same. But okay. Sure. String receiver name is equal context or simple and then symbol is equal. Oh, so it's got rid of this. I guess that makes sense. Like, that doesn't need to exist anymore. I mean, let's just try it. See what happens. It's very insistent that is the issue, so it's not because it hasn't fixed anything. But sure, I will update your tests as well. Okay, one of the tests now passed. See what it says. How much status do I even have left? That's okay. That's not too bad. Okay, so resolved symbol is empty. Okay. So it's empty, right? What is all this shenanigans? Oh goodness gracious. Bro, oh my god. I actually, after we've done this one, I'm going to turn caveman on because it's just saying way too much. We're just going to vibe this out, guys. We're going to vibe code it and see if it can do it or not. But I need my freaking caveman because I don't want it to say this much. Okay, I see what it's doing. Okay, yeah, that makes more sense. I don't know why we didn't do that originally. Yeah, okay, because you have to get the type preference. Yeah, why didn't we just do that originally? I don't know. I think I thought I could be smart, but apparently not. Can't you turn it on now? No, it's running. Can't turn it on whilst it's running. Let's see. Nope. It hasn't changed diddly squats. Right, okay. Alright, so we've got caveman on. And let's just give it the whole thing again. Wait, yeah, that's fine, right? Yeah. Wait, how much context do I have? 34%. I think that's fine. Possibly. Okay, but let's make it caveman anyways, and then at least it will say less. Hopefully. Still broken. New clue clear. I will take that. Yes. Resolve qualified type name also bad. Return optional string not optional. Need to stop using semantic type name for optional. I don't know that's right. I don't think this is right, but we'll try it, sure. Does that mean these are now useless? No, these still exist. Okay, interesting. We'll see what that does, I guess. If anything. I feel like that isn't the issue, but I could be wrong. Yep, I was wrong. That was the issue, apparently. Okay. Wait. Oh. Oh. I see what was happening. Okay, it's not what I thought it was. Okay, I see what's happening. I thought what was going on is that it was saying like, well, I don't really know what I thought, but I thought it was basically saying like optional string was causing problems, right? And it couldn't figure out what optional string was. But no, what it's saying is that an optional of type string was being converted to optional string, which is why it was failing, because it didn't understand that. That's what was happening. That makes sense. So now it just manually just converts them to be these. That makes much more sense. Though I feel like we shouldn't have this. Can't I just get rid of that? See what happens if I get rid of that. See if the tests fail or not. Nope, they all pass. Well, that's fine then, in it. Okay. So that one is... Oh, wait, lambdas. Lambdas. Okay, let's speak caveman to it as well. Let's also compact as well. So we have a little more context to work with without it just resetting halfway through our instruction. Right, I've got one of those freaking skin things on my finger. You know when like the skin is like coming off. It's so friggin' painful, but you're not meant to pull them out, right? Because apparently you can get like infections and shit when you do that. It's meant to be like really bad to do that. But they're just so annoying. Who invented these? Bad. Terrible invention. I think we have to caveman again. So I don't know. Not sure. I actually don't know we do. Maybe. Regardless. Let's... Yeah, okay. So... I need to make it so if .get is called inside is present, if present, then that's fine. Then that's considered safe. How would I do that? It's not going to use caveman. Maybe it will. Let's see. What is OpenAI Codex? OpenAI Codex is basically ChatGPT but in terminal, I guess. Oh, okay, it actually is using caveman. Read code first. Yeah. Okay, it's actually looking. Okay, it hasn't cavemaned the friggin' response though, has it? What the hell is there? Yeah, let me bring it over so I can have a look at what it's saying. So if a report optional get. Okay, yeah, so we just need another method then, basically, is what it's saying. So we want to add another one, add those, and then just create this method, right? So it's given me like most of it. we're going to try and use at least kind of as much as possible. So we can do context dot nodes of kind, and yeah, basically just get all the method invocations, because we want to look for the if present method invocations, right? So we can do method invocation and do for, this will be the invocation. Then we can do if not context dot is method invocation named if present. Then we can get the receiver. That is correct, right? Yeah. Context dot unwrap transparent expression. Context for invocation receiver. If the receiver is null or it's not an optional receiver, continue. String receiver name. That's null or blank, continue. And then we do syntax node lambda. Yeah, we don't have a first argument. Okay, first lambda argument. We'll create that in a second. And then syntax node lambda body. Yeah, we don't have that either, but we should probably create that actually. Lambda body of. And then boom, and then collects like that. Okay, then let's create this one. Lambda. No, this isn't a lambda. This is the invocation. Are you still working on the optional one? Yes, we are. But we are almost done with it, so that's good. So we want the argument list will be not like that. We're going to do context.direct child and then just do argument list. Okay. And then just do argument list.children.for child if objects.equals a lambda expression. Then boom bada bing. And then return null. Now the only thing, well, no, I guess, yeah, because if the lambda is like a variable, then like it doesn't really make sense, does it? So let's take this. Let's find our body of method. This is the one I was looking for. Okay, then we'll do boolean scene arrow. Then we'll do lambda children for child if not scene arrow, and child is a syntax token, and the token dot kind dot equals token dot kind dot ID. No, we can just do and token dot text that equals token dot text, like that, right? And then if scene arrow and not child is instance of a syntax token, then return child, else return null, like that. And then I think that's basically it. Let me just ask it, can you write the tests for this? Okay, we'll get it to do those tests. Me add test for if present safe. I love Ooga Booga. It's great. I love the caveman shenanigans. If not exist, add test for multiple negation. Me add both even and odd many negation cases. Okay, let's check these tests then, shall we? I'm gonna tick this one off now, just because otherwise I'll probably forget to do it. One test failed. Uh-oh. What do we think it was? Lambda, or do we think it was negation? I think it's got to be lambda, right? It was negation. Why fail? Bro, still way too much yap, bro. Still way too much yap. I might need to enable friggin' ultra mode or whatever it is. I have no idea what the issue is. What's it saying? Wait. Oh, I didn't even call the methods? Wait, no, I did. Oh, this is in positive. I see. I see. Should I say, caveman. How do you do it? Caveman equals ultra or something? Me speak tiny now. Let's see. We'll test that out in a moment. Okay, that did actually fix it, yeah. Nice, okay, that's all done then. So we can commit that now. You're fine, you're fine, you're fine. These are probably all fine. Those are fine. Those are fine. Okay. That's done. Commit. Okay. We have an hour and 20 minutes, or hour 15. Let's try and find some other ones to do then. So I got Gemini actually to find me some high impact ones. So we're actually going to use these. Okay, so it says obviously one of the high impact ones is null ability, but obviously we'll leave that for a while, because that's, you know, a bit complicated. Next one is infinite recursion. Okay. Let's try this caveman then. Me want implement next. Please guide through steps. Let's see, does it speak tiny? Me look existing, cool flow inspect. Yeah, that's fine, I think. Okay, I think it's going to be able to do that. So, and let's start by adding the basics, right? So that means adding a semantic rule. So Java semantic rule, and we'll call this it's just infinite recursion, right? Okay, by the way, guys, it has not gone tiny. It's like really yapping right now. Like, holy moly. Just gonna go back to what it said at the start, please. So infinite recursion method recursively being called about base case leads. Yeah, sure. Let's put warning. No, let's put error, but Codex said warning. I mean, I think error is probably fine for this kind of, well, no, well, yeah, probably warning, I guess. Sure, yeah. Okay, then let's create the inspection class as well. Then we'll create a new class. Implement Java inspection rule provider. We're gonna want the usual shenanigans. Okay, what's going on? Missing you. Okay, we also wanna do that. And that. Okay, what's going on there? Oh, that. Okay. So I think we want to start by I think we want to start by finding the method declarations, right? That makes sense. And then we'll just basically scan the bodies, I guess. So context.nodes of kind, we'll do Java syntax kinds dot method declaration for method. We'll do syntax node body is equal context.directChild, and we're looking for just block. If there's no body, that's fine. And then symbol method symbol is equal context dot declared symbol method, or else null. If that's null, continue. Then if is immediately infinite recursive, then we'll report that. And give it method name as well. So we need to get the name, don't we? String. We can get the simple name later. Because that needs to pass in method. Okay. So I mean, let's think. Yeah, is that a thing? That's not a thing though. We can do well, I'm just thinking, should we do context dot reverse descendants? Maybe could be the way to do that. So I mean, we have well, okay, I think what we want to do is we want to have a method that can analyze any syntax node and figure out if it's recursive or not, right? So like, yeah, we could do the logic in here to traverse the children, but ideally we just have like a method that does it for blocks, because obviously you could just have a block in the body. So let's have like a private static. We'll make it void for now because I don't really know what we're going to return, and we'll have like a analyze flow, which can take in our context, of course. Can take in the syntax node, which is the node, and then it will take in the symbol, which is the method symbol, which obviously we use to then compare against said method. And then basically best thing that I can think is just return switch on that. Yeah, you can't do that. It thinks you can do that as well, but you can't do that. So we'll do Java block, which will be analyze block, Then we'll do Java return statement, Java expression statement, if statement, we can do this loop, and then I think we also want throw statement. I don't know if we need switch or not. We're doing false there, but we don't want that. Let's create a record we can use. Flow is infinite recursive has return. I think our second boolean needs to be sure, yeah, that's what I was looking for. And then let's just create some options that we can have. So let's have recurses. Let's have dots, and then let's have pulls through, right? Which is, yeah, that one. And then here we can just return this and return falls through there. Okay, and then let's start with analyze block. So I'm going to take basically this, rename that. Okay. And then we just go through the children. So block.children. We haven't called it block. This should be called block. Block.children.for. If child is a syntax token, continue because don't care. And then yeah, right. If result dot is infinite recursive, return result. If the result cannot complete normally, then return result. And then return pulls through. We're kind of just doing, well, no, I guess that's fine, isn't it, actually? Should we just do an or statement here? Yeah. And then we'll do the next one. Which will be analyze return statement. Which this will be the return statement. I guess it's kind of similar. Like, kind of. Continue, and then we need to know if contains direct self call, then it recurses, otherwise it returns stop. Oh, wait, The hell did I just do? How have I just written that? Wait, where's the block code gone? Oh, I see what I did. Silly me. Return state. Then we can do that. There we go. Okay, we'll come back to that method because I think basically all of these are going to need that method. This is basically the same, right? Yeah, I think so. And then if statements are a little bit more complicated, I mean, this is probably correct. Kind of. This isn't right though. So the then branch is just context.then branch. And that's just else branch. This I think is just a little bit unnecessarily complicated. If then branch is null, yeah, and then if that's null, return we want false true here, which is false true. Okay. Infinite recursive can complete normally. Yeah, that's fine. Okay. And then we've got loop and throw. So wait. No. We don't need those, do we? So like loops. Well, a loop just falls through. Right? Just because like that's asked to try and figure out. Maybe we come back to that at some point, but like we'll do that for now. And yeah, this just throws an exception, right? So it can't really be infinite recursive. You should stream on Twitch without the music. Why? Why would I not have the music if I was streaming on Twitch? That doesn't make sense. And then, yeah, we need our big boy method as well. Context, node, method symbol. Find ID. If objects dot equals Java syntax kinds dot lambda find ID, then return false. Yeah, because that's like not really infinite recursion at that point. And then if it's a method invocation, I mean that's correct, right? The only thing is like we need a better way to check it, because that's not quite gonna work. We'll have like a is same method. And then yeah, basically that. And then just return false. Yeah, that's fine. And then we just need to make this method. So is same method. We take in symbol method 1, symbol method 2. Yeah, kind of. Let's do string name 1 is equal method 1 dot qualified name. And we can do that, but that's not really ideal. So we also then want to get syntax node declaration 1, and then we can do declaration 1 dot let's do syntax node param list. We need the Java rule context. It doesn't really flat map, it just needs to map. Parameters 1, parameters 2. Let's just first of all do if, well, yeah, I guess. So if name1 does not equal name2, return false. What's Copilot doing here? I mean, sure. That makes sense. I see what it's doing. Okay. That makes sense. Yeah, so it's going through all those. Only thing is, I think it's going to be the parameter now. I'm not sure that's going to work, but we'll see. What's going on here? Is that correct? Yeah, that's fine, I think. Okay, I need to ask Codex about is same method. Let's see what it says. Okay, it's yapping again. So it says qualified name is already enough. No, it's not enough because the qualified name doesn't include the signature. Okay, as I thought, the children are not these. So what we can do is we can stream and map it, not filter it, to the param like that. And then that will work. Yeah, that's fine, I think. Let's just filter and say objects non-null, just in case, more than anything. Always returning true. Oh, can direct mode can return null though. I don't think that's true. Why is it insistent that that's not the case? Can I, how do you, a way to see why, no? Maybe I can't do that in this case. I feel like that's not the case. Oh, because if it returns no, it's automatically empty anyways. I see. Okay. Then that's fine. Okay, let me say, can you write the tests for this inspection? Let's add it to the registry real quick. Okay. Put it in here. Okay. Let's see. Let's write in the tests. I think it's honestly a pretty low chance this works first try, but oh dear, you never know. Okay, let's add them. Let's give it a run. Okay, they failed. But not all of them failed, so let's see what happened. and base case returns. Okay, so that's basically saying our return statement isn't working. So this one, analyze return statement. I guess let's try and debug it. Maybe we'll see. Let's have a look. Okay, so the return statement here is if we go into the green node, okay, and then we go into the children, we have return, we have a literal, yeah, that's fine. We have white space, and then we have an int. Wait, what? How is that the case? What inspection? What test are we in right now? This one. Oh, because that's the first return statement. Okay, right, that one's fine then, isn't it? Okay, so that one stops. Right. So that will come out of the if statement, right? Because that's inside of an if statement. Oh, but it has to analyze the block statement first, I see. So then it will come back to the if statement. Okay, so that's saying that falls through. Okay. So then we come back to the block statement. And we have the results. Okay. Then we should get to the next child, which should also be a return statement. Let's just check. So that's return. Then it's a method invocation with a name and an argument list. Okay, let's see if that's true. So we'll go in here. Okay, so it's a return statement. So we step into there. Then we go through the children. Yep, so the first one is that. But then this one. So this is child is now. The method invocation. Okay, so let's go into here. Okay, so method invocation. So that will be true. So then this should get the called symbol. So the called symbol is run, and the qualified name is example run. Okay, so let's go into is same method. We got name 1, we got name 2. Then we got parameter list and param list 2. Okay. What are the green nodes in here? Oh, you know what the issue is? Because we're just mapping it to be a parameter. Wait, no, is that fine? Possibly. If name 1 does not equal name 2, so they do equal, so that's fine. So then we do param list 1, we map each child to be a parameter. So what's param 1? Param's 1, so that's nothing. But if we look in param list 1, we go children. Okay, I know what we'll do. We'll filter and we'll say node. And we'll say node dot. We'll say objects dot equals parameter. And then we just won't map it. Right? I think that should fix it. I believe. Two tests failed. How many was it before, chat? Does anyone remember? I think it was 2 before, wasn't it? Or was it? Wait, let me run it again to see which ones failed. I think it was 2 before, though. Okay, so... yeah, okay. I think it must have been them. We'll try run it in debug again, and we'll see what happens. So hopefully it should hit here, and then what I'll do is I'll just press resume and it should bring us to the next one, which should be what we want. So we'll go into here. Okay, so we get into here and then get into here, and then we're exactly where we were before, right? So what is params 1? Still empty. Interesting. Oh, because that's getting direct expression children. Okay, what we want then is params 1.children. And here we want params 2.children. That's why that's not working. See if that works. Oh, wait. 1 second. We do need... So here we're filtering to make sure it is a parameter, but we're not mapping it to... Wait, are we? Yeah, we are. Yeah, because we're filtering it. So that's fine. I think. Not sure. I'll try again in a second. Okay, so we'll skip you. Okay, go into there. Skip, into skip. All of these. Okay, so we go through params 1. We filter out to see if it's a parameter. Hopefully params 1, yeah, is now height preference, white space, identifier. Okay. They're fine. Let's see what these are. So those are now both int. So then that returns true. So that returns true. So that returns true. And hopefully that should mean... Okay, that one's fixed. So now we just got to fix this other one then. So let's try and figure out what's going on with this one. So does not admit diagnostic when base case returns. But that is recursive. Oh. No, it's not. Because this has a return statement. Interesting. Where's the other one? Real quick. There's that one, but where's the other one, bro? Where's the wait, bro, where's the one we just had? Am I crazy? It wasn't this one. It was a base case one. I thought it was this one. Base case. Wait, was it this one? We're looking for an assert false. Wait, I'm so confused. Okay. Let's just give it to Codex and see what it says. Okay, so it says okay, it says it's fixed it. It's basically added another boolean. Let's see if that works. Nope. What's wrong? Oh, I see what it's done. Okay. I think this should work now. Nice. Julio. Okay, let's go ahead and take that one off. So stack overflow. Recur, infinite recursion. Okay. Honestly, guys, those were the only ones I had planned today. I mean, there are other ones I have on here, but like with half an hour left, we're not going to be able to do any of them. Because obviously I don't want to do any of the starter ones or easy ones, because I want to leave those for other people to do. So in regards to the only other ones we can do, they're just like too big to do in half an hour. Like we have auto closable used without charge of resources. That's a medium one. But it wouldn't be too hard, but it's just slightly too long for half an hour. Yeah, we have like unused declaration, which is kind of one of the really important ones we need to do at some point. honestly, guys, I think we're gonna go ahead and end the stream here. I will be live next week, or this week, I guess, this weekend. It's the Monday, isn't it? Okay, that's confusing. And we're gonna be back with an industrial stream this weekend, so expect to see that back. But I'm gonna end it here. I hope you all enjoyed. If you're not in the Discord, join the Discord. Good that I'm remembering to say that again. I will see you all at the weekend. Goodbye.